Hello students, in this video we will see some shortcut formulas for problems solving in two-dimension motion, that means projectile motion, and we will also see different projectile motions like horizontal projectile motion and some other case like inclined projectile motion on inclined plane, right? How to approach such questions. So let's discuss this. So we have seen oblique projectile motion, right? Oblique projectile motion. So here I am not going to again discuss in detail about it, but some important results we can discuss. So time of flight formula is 2u sin theta by g, right? Or 2u y by g, same thing. Another important thing to note is that range. The range formula is u square sin 2 theta by g, right? So u square sin 2 theta by g. Here we can think about maximum range. So range can be maximum, right, when sin 2 theta is maximum, right? So that means 2 theta is going to be 90 degree, theta will be 45, right? So when theta is 45 degree, range is going to be maximum, right? Then next, H max, u square sin square theta by 2g, right? Here if you want to find a maximum height, H max will be maximum when it is u square by 2g. That means sin square theta is going to be 1, right? That means theta is equal to 90 degree. These are two different conditions. Okay, we want maximum value of H max, and this is maximum value of range. Okay, another thing that we can notice, if I take the ratio of H max and range, what do we get? Okay, let's take ratio of H max by range. So u square by g factor will get cancelled. You will get sin square theta by 2, correct? And here sin 2 theta is there, which you can write as 2 sin theta cos 2. So one sin theta will get cancelled, and we will see that it becomes tan theta by 2. So this is an important result where you can use this ratio. H max by R ratio is tan theta by 4. Tan theta by 4. This result can be used in some questions. Okay. Now there is another thing to note is about the same range. We can have same range. So there will be some conditions for throwing the body. Let us say that this is a body and we are going to project it. Same speeds and other things are same, but only theta is going to be different. Let's say you project like this, another time you project it like this. So first time when you are projecting, you will see that this is the, let's say it is going like this. Second time when you are projected like this, you may go like this and again it will come. Okay. So these two are different projectile motions because the angle of projections are different. First time it is, let's say, theta. Second time, how much it will be? That is going to be 90 minus theta. This we will understand. Okay. So same range. One time the angle with theta, another time the angle is 90 minus theta. Why this is for the same range? Now let's understand the formula for range. Range formula is u square sin 2 theta by g, which you can write as u square 2 sin theta cos theta by g, right? So if I keep angle as theta, then sin theta cos theta is product, right? If I replace theta with 90 degree minus theta, then sin will become cos, cos will become sin, right? Then it will become u square by g, 2 will become cos, cos will become sin, right? because sin 90 minus theta is cos, isn't it? So sin and cos will interchange, but the product is going to remain same. That is why they will have same range. So if we are using angle theta and angle 90 minus theta, we will have same range. Range will be same. But other things are going to be different. For example, here if you see the time of flight for the first one. Let's say this is the first projectile motion, this is second projectile motion. So time of flight for the first one will be 2u sin theta by g, right? Time of flight for the second one will be 2u sin 90 minus theta will become cos theta by g. Okay, so here we can get the relationship of T1 T2. So T1 square plus T2 square if you do, you see this will come square, so 4u square by g square, like this. There is a relationship, right, between this. So this is one equation that we can. Similarly, if you take h max for the first case, h max 1, h max 2. So this is for the first case. Let's say this is h1, h1. For second case, maximum height will be here, right? This is h2. So there also relationships we can get. So let's write that h1, h2. So suppose if I write the h1 first, h1 max is u square sin 2 theta by g, u square sin square theta by g. So u square sin square theta by 2g, right? U square sin square theta by 2g. h2 will be what? h2 will be u square sin. So sin 90 minus theta will become cos. So this will become cos square theta by 2g. Now you can add this, right? So you can add h1 plus h2. h1 plus h2 you will get u squared by 2g. So this is also results on h1, h2. Okay. Now also important to note that product also you can calculate. If you take this product h1 h2 into h2, what it comes? So you will see u square by 2g whole square will come, and even you can bring inside sin theta cos, right? Sin theta cos theta inside. Okay. Now you can try to bring in terms of range. So you can multiply 2 and divide by 2. What do you get now? So you will get u square sin 2 theta by g, and 4 you can bring this set. Okay. So u square sin 2 theta by g is nothing but range. So this is going to become range by 4 whole square, isn't it? So from here you should know that range is nothing but 4 root under h1 h2. All these relationships can be asked in objective questions. So better we should remember these formulas, these important results, right? So I think these are important things here. I think one more point we can write, point number 6 for the trajectory. Okay, let's write for the trajectory equation. Trajectory equation we have seen y is equal to x tan theta minus half g x square by u square cos square theta. Now this can also be written as x tan theta. If you take common, right, it can be arranged and it will become x, right, and it will become r. You can just check that. So r, if you put r is nothing but u square sin 2 theta, because here tan theta you have taken common, so you have to do some multiplication here, and this will transform into this equation. Okay, so this is another form of writing the projectile motion. In terms of range we can write it. It can be useful in some questions, right? Okay, so these are some results. Then let us see some case studies in this. One case study in oblique projectile motion will be like, suppose if a body is projected with a speed, let us say a body is projected with a speed u, at an angle of theta with the horizontal. Okay. Now this body will be going like this. Okay, projectile motion. Now they can ask you that at some point of time, this body will be making some angle, different angle it will make. So this is the initial velocity vector, and sometimes the velocity vector can be making with the horizontal maybe different angle. It will, let us say now it is, so you can see the theta is decreasing, and here theta is going to become 0, right? And at this point, let's say this angle is alpha, and here this velocity is v vector. Sometimes the question can be when the initial velocity and final velocity vector become perpendicular to each other. So this is initial velocity vector, this is an instant velocity vector, when they can become perpendicular. So we can try to find a resultant, or a different approach for general. So let's say this is the initial velocity vector, and after some time this is the final vector. So of course with the horizontal we know the angle, right? So this angle will be how much? This, let's say theta minus alpha, right? Because first one is making theta, second is making alpha with horizontal, then this will become theta minus alpha. How do we calculate the angle between these, right, two factors? Whatever this angle will be, how to calculate that? Okay. So we can write vectors and take dot product. So v is equal to u plus at, and here of course minus at it is. Okay. So if you want u vector, you can break here, because this acceleration is in the downward direction, right? So minus gt jk. U vector can be written as ux I cap plus vy j cap minus ct j cap, right? So you can club that together, ux I cap plus uy minus ct j cap, right? This is the velocity vector at the instant of time. And what is initial velocity vector? Initial velocity vector is just ux I cap plus uy ct. Okay. Now suppose if they say that what is the angle theta at an instant of time, so v dot u, you can calculate. What is v dot u? V dot u, when you do here, you have to multiply the corresponding terms, right? Ux and this y component also. So what do you get? You will get ux square plus uy into uy minus ct. Okay. This is what we are going to get, and you can club this together, x square plus uy square, you can put together, minus g into uy input, right? This is what is v dot u. Now suppose they say that they both the vectors are perpendicular, then this angle between them becomes 90 degrees, so v dot u becomes 0, right? So if v is perpendicular to u, so v dot u becomes 0. Let's apply this condition here. What do we get? Let's see. So this must be 0, and ux square plus uy square is initial velocity square minus g into uy. Uy can also be written as u sin theta into t. So you can calculate from here time. So one you will get cancelled, you will get u by g sin theta. So this result can be noted for the velocity vectors to become perpendicular, right? We can note down this because this can be used in the. So at what time the velocities become perpendicular? Time is u by g sin theta. This is just an approach, and various case studies can be made, but the idea is that how do we take these steps, what's the basic concept, right? Okay, so this is how we can solve questions like that. That can be many case systems. Okay, so this is about oblique projectile motion and some things we have seen. Now let us see some variation here, that is about horizontal projectile motion. Okay, horizontal projectile motion. Horizontal projectile motion. So horizontal projectile motion, how does it work? Horizontal projectile motion. So it's like the ball or the object is projected from some height. Okay, so this is the object, let us say, and you want to now project from here. Right? This is the object and you are projecting it here. You can project it like this with a speed v. Now here the trajectory will be like this. It will go and it will be, of course, going like this. Isn't it? This is the projectile. Suppose this is the ground and it will reach the ground after some time. Right? It will come here. It will reach. So it will hit the ground with a different velocity. Right? It will be hitting here with a velocity like this. Again here there will be x component and y component. This is the vx and this is the vy. Right? And remember, horizontal component remains constant, that remains same. So this is the horizontal component, because initially it was a horizontal velocity only it has. So horizontal component doesn't change, vertical component is changing, and let's say this is the height h. So initially the vertical component was not there. Initially in the vertical direction it is like drop, object is drop, right? So we can calculate Vy directly. Vy can be calculated as root under, and use this initially 0, root 2gh directly we can use. One dimensional free fall, we have seen those concepts, we can directly apply. Okay, and once you know that, we can also calculate this angle. This angle is, let's say, theta here. So here tan theta we can calculate as Vy by Vx. So Vy is root under 2gh and this is u. So we will be able to calculate this angle theta. Correct. Okay, another thing is that how much time it takes. So time, just vertical motion you can study. Time is equal to root under h by g. We are directly going to use those formulas. And what is the range here now? This range. So range will be again in the same manner. Range is equal to speed in that direction into time, because x-axis there is no acceleration, so uniform motion. Time you can substitute, so u root under 2h. Correct. That's what it will be. Okay. Right. So this is about horizontal projectile motion. How any result in this? Yes, there can be one result. Suppose if you try to join this point, let's say you join this initial point and this point. So there can be this angle. Let us say this angle is alpha, or this is the angle which the initial velocity vector is making with the line joining this, right? So what is this angle alpha? You see tan alpha from here. Tan alpha becomes is equal to h by r, because this is 90 degree. Now h by r. What is range? Range is u root under 2h by g. So from here you will see that you can put it inside. So it will be 1 by u root under g by 2h. Okay? Because this h will be under root. So this you can take root under u by root under h square you can take inside. So I think it will be gh by. Okay, this is what you will do. So this is the tan alpha and that's tan theta. There is a relationship between them. So if you take the ratio of tan theta by tan alpha, tan theta by tan alpha, so what we get? So here tan theta is root 2 gh by u, and you will see that this is root under gh by 2 divided by u. So you will get cancelled here, right? Even gh factor will get cancelled. What you will get from here? You will get root 2. So that's why tan theta is going to be 2 times tan alpha. This is one result in horizontal projectile motion which you can follow, right? Can be used in objective questions. Okay, so this is what it is. I think horizontal projectile motion. Then let us take projectile motion in inclined plane. That we are not going to discuss in more detail. The approach we'll discuss, and then you can do it. You can make option results by your own, right? So projectile motion on inclined projectile motion inclined plane. Okay, so let us say that there is an inclined plane like this. Okay, and this is the horizontal plane. This is, you can take this angle as theta, right? Let's say this angle is, or let's say this angle is alpha, right? And the object is being projected. Let's say this is an object. This object is being projected from the plane in this direction. Okay, some projection has been made. Let us say this is projected in this direction. Okay, now this angle you can take as beta. This angle is beta. Okay, now what will be the path? So path will be that it will go in this manner. It is going to move like this. Okay, like this it will go, and you can assume that it is sufficiently large. So there are calculations here, like for example, here first of all we should take this as x-axis and this as y-axis. Now the x and y-axis are not the same as usual. Along the inclined plane, that is the x-axis perpendicular to that outward direction is y-axis, and this is the speed u. So now we are going to resolve the speed u into two components. One is along this direction, which will be called ux, and this will be direction which will be u1. Okay, so here ux is u cos beta and uy is u sin beta, right? This is what it is. So when it is going to hit it here, again we can calculate all the important terms, right? So here this is the maximum height, you can say, but this maximum height is with respect to the plane, inclined. Similarly, the range will be along the inclined plane, how much distance it is going to hit it. Okay, so range, again time also, when time is 0 here, then some time capital T, time of flight. How do we calculate here? Here you need to note one important thing, that acceleration due to gravity, which is acting in this direction, vertically downward direction, you have to first of all resolve it along the plane and perpendicular to plane. So in this direction, first of all you should know that this is the same angle alpha. So this direction is g cos alpha, and this direction is g sin alpha. Okay, so we are going to take acceleration components along x-axis. So acceleration component along x-axis is minus g sin alpha, and acceleration component along y-axis is minus g cos. Here this direction is taken as positive and opposite direction is taken as negative. Perpendicular outward is positive and perpendicular downward is negative. Okay, so based on this we have defined this x-axis, y-axis, and we are taking it like that. Remember, here both directions along the x-axis, y-axis are uniformly accelerated motion. Right? In the same way we can do the calculation. Let us do the calculation for time of flight. So again, in time of flight, that means y-axis motion you study, y-axis motion. In y-axis motion, when you are studying, you can see displacement y is 0. So ut plus half at square, half at square. Again, this is along y-axis. So this y has to be 0, and this is uy t minus half ay into t square. So from here, again two roots will come, but we are interested in time of flight. So time will be 0 and another will be 2 uy by a1. So here the time of flight will be 2 uy by a1. What is ay value? Of course here minus I have put, so this is just the magnitude of that. Okay, here with the sign. If you want, you can keep just as a1, and here it will be minus a1. So when you substitute here exactly, then you get 2 uy. Uy value also, if you want, you can substitute. Otherwise, that is the ay is equal to g cos. Okay, so here the time of flight t will be given by this equation. 2 uy is u sin beta, right, by g cos. The time of flight will be given by this equation. Same manner we can think of calculating the Hmax. Hmax first we can calculate what will be Hmax. So Hmax calculation is again y-axis motion only you have started, right? So that means this when it is going like this direction, it will have no velocity. Okay, and initial velocity along y-axis is this uy, and acceleration is in this direction a1. So let's apply this. V square is equal to u square plus 2a. This is Hmax, right? This is y along y-axis we are applying. So when you apply this, final velocity will be 0. This is uy square plus 2ay into Hmax. So from here Hmax comes out to be uy square minus 2a. Okay, minus 2a. Now you can substitute the value here. So ay is minus g cos alpha, so it will become u square by, and what is uy? Uy is u sin beta, so you can substitute that u square sin square beta by 2g cos alpha. Okay, this is Hmax. So we get the idea about Hmax. What is Hmax? Okay, now remaining is range. Let us see the range. What will be the range? Okay, so if we are going to see the range, this total R, so this range is again, but this is not a uniform motion. This time there is expression along x-axis in negative direction. So it is minus g sin of alpha, right? So this range you will calculate as ut plus half at square. Okay, this t will be the time of flight, and this is along x-axis. So now substitute ux along x-axis is u cos, right, u of cos beta, and this time t which we have calculated, that we can substitute 2u sin beta by g cos alpha, 2u sin beta by g cos beta. Okay, plus here minus will come because acceleration is negative, so minus half. Acceleration here is g sin alpha, and t square means this time, right? So 2u sin beta by g cos alpha whole square. So you can expand it and calculate for this range. So if you expand it, what do you get? 2u square by g is coming, right? And this is sin beta cos beta divided by cos alpha, right? Minus here also 2 square 2 will come, right? And u square by g factor also will be there. but here there will be sine alpha and sine square beta, okay, divided by cos square alpha. Okay. So you may little bit simplify it further to calculate g cos alpha. You can take out. So some terms I think we will be able to take out, right? And then you can further simplify it. Obviously 2u squared by g factor will come out, isn't it? So then you can simplify it further. Then maxima minima concepts can be applied here. Okay, suppose if I take 2 squared by g cos alpha out, then what do we left with? We left with sine beta cos beta, right? Minus, here it will be 2u squared by g comes out, so sine alpha, even sine beta can be taken out, isn't it? Take sine beta out. Suppose if I take sine beta out, and if I take cos square alpha instead of just cos alpha, suppose if I take cos square alpha, so here what do we get? We will get cos alpha cos beta, right? Here we have taken sine beta, so we will get sine alpha sine beta. So you can see that this is getting arranged, right, into some terms. So range will become 2 square by g cos square alpha sine beta, and cos a cos b minus sin a sin b, so this will become cos alpha plus beta. Correct. This formula of range we can remember. If you can remember this, maybe directly we can substitute, right? So 2u square, some changes are there, right? So 2u square, instead of sin theta cos theta, it is sin beta cos alpha plus beta by g cos square alpha. Okay, this is what it is. We can remember this. Then there are some conditions for maximum range here. Okay, so for maximum range you can differentiate. Let's say theta is constant and you are changing only beta. Okay, so what is the condition for maximum range? Condition for maximum range. Maximum range condition, if you consider, then you can differentiate dr by, let's say, only variable is beta, right? Because alpha you take as constant. Alpha is constant, beta is variable. So what you can do is you can differentiate dr with respect to beta and take differentiate, right? So if you apply this condition, you will certainly get here. So 2u square by g cos square alpha is out, right? So they are constant. Then you need to differentiate sine beta into cos alpha plus beta with respect to beta, right? Is equal to 0. So if you differentiate this, what do you get? You can apply UV rule. So leave sine beta into differentiate cos. Cos becomes minus sine. Okay, so it will become minus sine of alpha plus beta. Similarly, if you leave cos alpha plus beta, then sine will become cos beta is equal to 0. So I think you can see that this is also become cos a cos b minus sin a sin b, so it will become cos a plus b, right? This will become 0. So from here you can say alpha plus 2 beta must be 90 degrees. This is the condition, right? This is the condition which we are getting. Alpha plus 2 beta must be 90. It's an important condition for inclined projectile motion. Okay, you can remember this results. There is a full derivation also here. Now what is the value of the range here? So if you can see here, range you can substitute. So alpha plus beta is, then alpha plus beta will become 90 degree minus beta. So this condition you can substitute R max. So R max can be calculated from here. So 2u square by g cos square alpha you can keep, 2u square by g cos square alpha you can keep, and then sin beta into sin beta into, then this is cos alpha plus beta, right? So cos alpha plus beta will be cos 90 degree, cos 90 minus beta. So again it will become sin beta. So 2u square sin square beta by g cos square beta. This is inverse. But there are different also ways how we can write it. Okay. Suppose if you want to write only in terms of beta, then you can also write alpha will be 90 minus beta, right? 90 minus 2 beta. So R max can also be written in that form. So if you write R max 2u square by g sin square beta by alpha will be 90 minus 2 beta. 90 minus 2 beta cos, that will become sin square beta, isn't it? Sin square 2 beta. Then further you can break it, sin square you can write as sin 2 sin theta cos theta. So range max can also be written as 2 will become 4, so u square by 2g will come, right? And this sin square beta will get cancelled, so you will be getting as cos square 2 beta, cos square beta you will get, right? So in this term also you can write, isn't it? Now cos square beta can also be written as different forms you can do. Okay. Further you can write in different form, but all these are important results. Okay. So motion on inclined plane we can do all the calculations related. We are clear about this. Once the concept is clear, then you can solve any type of questions in this, which max, range, time of flight, everything can be completed. Okay, so with this we are finding the topic of projectile motion. Then on problems we will work out further details. Thank you for your attention.